the atmosphere. It's partly by large-scale weather systems, but it's also by small-scale things like thunderstorms. In fact, we can see this at work, this problem. If we go to one of these climate models, and so you can see it's more like a kind of pointillist picture than the satellite map, and that's because we are getting down. You're seeing the granularity of the spherical harmonic truncations. The models actually do have a kind of shot at producing things like typhoons, but you see, the representations of these clouds and things is not nearly as kind of precise as in the real world, and that's because you're seeing the limitations of the computer, basically. 6 o'clock. Let me just. Do you have 5 minutes?
Yes, please. Yes.
I'm not going to go to the end of this talk. I'll just keep the last bit for tomorrow, to
keep us alert.
This is the sort of thing. You see, so you can say, are these models any good? And can I believe them for climate change? So I would say, yeah, they're very good because we test them every day in weather forecasting mode. And this is what my golfing friends say. Wait a minute, what about? And they always point to this guy. I don't know if people. This.
Yeah, I know. Well,
this is a Brit. This is a guy called Michael Fish. Now, poor Michael. Well, he's not so. I mean, Michael Fish has made a good living out of this forecast. So I say poor Michael Fish.
It's his hurricane that destroyed my caravan.
Oh, is it?
Brand new caravan.
I may have a picture of your caravan. In
2 weeks old it was, my caravan, and this guy destroyed it.
In October 1987, he said, "Don't worry." Actually, there's a story. Ask me afterwards why he said this. But anyway,
it's so good. You have to say it now. He said a lady in Bournemouth, was it, rang me up this afternoon to say there's a hurricane on the way. Don't worry, there's no hurricane.
No, but the more interesting question is that the lady was actually from France.
Oh.
And the question is, why did she know, or why did she think there was a hurricane on the way? That's the interesting question.
Ah.
And I'll tell you that over dinner. But anyway, he said on the news, don't worry, this lady's phoned up thinking there's a hurricane on the way. Don't worry, don't be so stupid. England doesn't have hurricanes, there won't be a hurricane. And sure enough, a few hours later, trees were blown over, there's more trees blown over. There's Basil's caravan. And maybe that's your car as well.
No, my car was all right.
So, and the town of Sevenoaks in Kent was reduced to no Oaks. And this was a sort of.
Did they change their name?
And there's Basil's. There's Basil's private area.
Just to give people who obviously weren't in England at the time an impression, almost 3/4 of the trees in Windsor Great Park were uplifted and down. It was
Which year was it?
1987, October 1987. About 13.
So this is actually a great example of chaos in action, because this is actually a kind of retrospective forecast that we did, actually with our latest models, but going back to 1987 conditions. And what you're actually looking at here I can't actually remember now. I think this was the. These are surface pressure maps. So this was our best estimate of what the surface pressure, what the weather, if you like, was like over the Atlantic. This was just a couple of days before the storm. And this is one where I have just essentially added flaps of butterflies' wings to the initial conditions. They, by eye, you'd be hard pressed to see much difference, but they're very, very slightly different. And if we let this thing go, so we're going to animate this. So this is the computer taking these initial conditions forward onto the morning of the storm. Wow. Now, this is what friend Michael Fish. I mean, it wasn't his fault, because this was the guidance he was given basically by the Met Office.
By the Met Office.
No. I wasn't hardly born in 1987. Well, I was born. Now, weather forecasts are looking at this map. This would be the morning. This is 66 hours, so this is 12 o'clock. So that's 6 o'clock in the morning of the, whatever it is, 16th, 15th of October. This is actually a little ridge of high pressure. So what he would probably have said is, well, after some little small disturbance which would clear away early in the morning, we'll basically have a fine day. However, a little flap of a butterfly's wings to the initial condition, and this is a very intense, deep depression, and if he had that forecast, he would certainly have been able to warn people to
Want me to
back-
move my
batten
caravan?
back down the hatches.
What was the length of the whole evolution?
This was actually a 66 hours.
So
this
when
was
you
60
just started the show, it's 66 hours.
Yeah, but I've
Okay.
shown it. This is 66 hours into the forecast, so it was from a couple of days before. So this is actually a nice example of chaos in action. So this was this is Lorentz, and it shows the same thing. This is the 3-component model now, not a 10 million component, which the weather one is. But you see the same thing. Start with virtually identical initial conditions, and you develop completely uncorrelated time series after a certain time. This is stuff you all know. So, except you don't know this. Lorentz never really wrote about butterflies flapping their wings. He talked about seagulls flapping their wings and changing the course of the weather. So it's a bit like Macbeth. He never said, or Hamlet rather. He never said, "Alas, poor Yorick, I knew him well." But everyone thinks he does. So Lorentz actually never talked about butterflies. Anyway, chaos theory. There's all sorts of roles, even in quantum physics, I would claim. So what do we do these days? Because, in 2006, it's still the same, we're still facing the same problem. What we can do these days is actually, and forecasts these days are based on this type of approach. We don't just run a single forecast. We run the model many, many times, here 50 times, with very slightly perturbed initial conditions. And so this is a rerun of that October 87 case. And what you see is, a number of the individual forecasts have developed these very strong storms. Other ones don't have it at all. So a forecaster, modern-day Michael Fish, would actually be able to, first of all, see that this was extremely unpredictable. I mean, this is an extremely... normally weather is much more predictable at this range. So we're actually on a part of the attractor near where all those kind of instabilities are. It's where the local Lyapunov exponents are just exploding.
Blowing up.
And so that's the first thing he would see, that it's actually very difficult to make any sort of definite prediction. However, he would be able to at least alert people of a risk or a probability. And in fact, you can even, this is what we do now, we put this all into a probability map. And this shows the probability of
just where that pointer is was my caravan.
Yeah, well, but Basil, this is precisely the point now. What he would say is the probability of Beaufort force 12, so basically hurricane force winds, is about 40%. Now, it's still less than likely, if you like, a priori. It's less than likely that it will happen. But it's up to you, Basil, to make that, and this is the current theory of weather forecast. It's up to you to decide, do you want to kind of tie your caravan down or whatever. If you don't value it very much...
Move it from under the tree.
Yeah. But it's what, this is where the notion of risk comes in. You multiply the probability by the economic loss to you. So if the caravan is only worth £5, then you may need an 80 or 90% probability before you tie it down. But if it's worth, £50,000, then maybe only 10%.
I don't have that sort of caravan.
Now, chaos plays a role in climate, and I'm going to stop actually in 2 seconds. But this is my model of climate. So, chaos. The climate. This is a kind of a mechanical analog. This is not exactly chaotic because it eventually stops. But whilst it's oscillating round these magnets, it's kind of the time series of magnets is sensitive to how you start the pendulum. So I'm thinking of these as weather states. Now, doing a long-range prediction of which weather states it stops there, so it's not precisely chaotic. You can't predict in detail over a long period which magnets it's going to. But you can say the probability of it going to any one of them is 25%. So at any one time, if you forget about the transition times, it's got a 25% chance of being under any one of the magnets. Now, climate change, and going back to talk about climate change, is